Hello, paper two. Sorry this is taking till the night before to get on. Hopefully you got enough time to get to watch this and have tried some of this paper two revision. There's no need for a separate sheet here. This covers everything and more than you're going to need for this exam, okay? I'll blast through. I might leave certain bits out and things, but to one significant figure, the one I'm going to look at here is this one. So to round this to one significant figure, we need to look at the first digit. The first digit is 3. That 3 is in the hundreds column, so the value of that 3 is 300. So in this case, we need to round to the nearest 100, okay? So the nearest 100 here would be 400, whereas here, the first digit here is in the tens column. It's 7 in the 70, all right? But because it's 76, it would round up to 80. So that's one significant figure. Two significant figures. Again, let's look at this one here. The second significant figure here is 3. That's in the tens column. So I'd be asking you to round this amount of money to the nearest 10. So to the nearest 10, this amount of money would round to £430. Okay. Or here, the second significant figure is the 8. It's again in the tens column. So the 9 wouldn't change, and the 87 would round up to 90. So you can see then there's two significant figures there compared to only one there. And then you're followed by zeros. Okay, write down the first three terms of, I'll do the harder one, okay? We need to know that 2n means 2 times n take away 6. And if you want the first three numbers in this sequence, the first number would be swapping that n here for the number 1. So we would do 2 times 1 take away 6. Well, 2 times 1 is 2, take away 6, that's minus 4. The second term would be 2 times 2 take away 6, which is minus 2. And the third term would be 2 times 3 take away 6, which is 6 take away 6, which is z. Well, same here, you do 3 times 1, add 2, 3 times 2, add 2, etc. And then if you wanted the 10th term, obviously you just swap, like I'll do that one for this one, you'd swap n for 10, so you do 3 times 10 plus 2. So the 10th term would be 32. The opposite of that is what is the nth term? So we take a look at this one. This one's going up in 3s, so it'd be 3n. This one's going up in 2s, so it'd be 2n. Okay, and then to find out what the kind of other part of this, we need to go back a number, right? Like what would come before the sequence started. So if I went down in 3s here, if I went down 3 from 2, I'd go down to minus 1. That would go on to the end there. If I went down 2 from 9, that would be 7. So we need to know how to do nth term like that, okay? Simplify these expressions. I'm going to take the hardest ones. Just be careful, right? Something like that. We wouldn't write it there, but that's 1p. So this would be 3p plus 2p, take away 1p. So 5. Nope, that's a lie. Take away the 1 would be 4p. Okay, let's look at the harder ones. Have I got harder ones here? Yeah, okay. Let's take a look at these. So here, simplify is the question, okay? Simplify. Start with 12a, take away 3. We're down to 9a. Then look at the x's. Start with 7x, take away 2. We're still in the positives, okay? Compared to here, this is the one that people get wrong. Start with 10x, add 2. Everyone in set 1, I guess, will get that right, okay? But what people, just all the people see then is 5y, and it's not. That's where we're starting on the number line, is minus 5y. And then we're going down another 3 on the number line. So if you think of a number line as minus 5 being there, and then if we went down 3, we'd end up down at minus 8. So there's minus 8y. So just be careful to do each one on a number line, okay? Right, some expressions. Again, I'm going to jump ahead, look at something like this. Okay, this one. Okay, 4 times 2 is 8. Okay, x is x squared times x cubed. Well, we know if we times letters, we can add the indices. So there'd be 5 of those. And then y3 and y4 times it together, we total y7. Dividing the same. Okay. Dividing the same. Let's just take a look at this one here. 16 divided by 8 is 2. X squared divided by x, think of that as x1. So when we're dividing, we're taking away the little numbers, the indices, so there'll be 1x left. 2 take away 1, just 1. And y, and there's nothing to take away from away from that, so that's just that. And the one underneath, 21 divided by 7 is 3. X cubed divided by x is x squared. And y divided by y, actually, in this case, would just cancel. It's like doing 1 take away 1, so there's no y's there at all, okay? Again, just make sure I'm just checking random ones in here. Again, look, 18 divided by 6 is 3. 8 take away 4 is 4. So if we times the numbers and add the indices. If you divide the numbers and take away the indices. Expanded single brackets. All right, chaps, we're better than that. Okay, I'm just going to go straight to one of these more tricky ones. So single bracket here, times these both by 4, times that by 4, times that by 4. This bracket, times them both by 3, plus 6x, plus 15. Then the simplify bit is what we've just done. Start with 8x. I'm adding 6 more on, so there's 14x's. And then the bit that goes wrong again, because people just see 4. But it's not, it's minus 4. That's where we're starting on the number line. And we're adding 15 on. So we go up to 11. Look, with this one, I will pick up on this quickly. I'm flying through this really, but times those both by 2, not a problem. The issue here is you're timesing this bracket by minus 2. So minus 2 times 2x is minus 4x, but harder than that is minus 2 times minus 3. Because this is a time sum, a minus times a minus makes a plus. Okay, so what do we end up with? 6x's, and then we've got plus 6 and plus another 6, so plus 12. 2 trifles cost £7. Start with what does 1 cost? 3.50 or 3.5 for a minute, okay? So 6 trifles would cost 3.5 times 6. So proportion, work out the cost of 1. It's called the unitary method for proportion. Don't worry about what 2 costs. Get what 1 costs, and then we can find out the cost of any amount that we want. Recipes, not so interested in for a minute, okay? Even these, I'm not overly concerned. Oh, look, let's just go with it, okay? Change, if ever you've got to order things like this, right, change them to percentages. So this guy here is 50%. This one over here is 5%. Okay. The hardest one is fractions. How do I change a fraction into a percentage? Okay. Well, you've actually got a calculator tomorrow. All right. So even though this was non-calculator, with a calculator, you can just times by 100. You can just, all right, that'll do it. The same with the decimal. You can just times the decimal by 100. Fractions of decimals are both times 100 to make them into percentages. So you'll get, if you put that into your calculator, you'll get that that's 20%. The alternative without the calculator, I don't know why I'm going into this, is to make the bottom number of the fraction be 100. So you kind of go in, well, I need to times that by 20. So I'll do the same to the top. So 1 over 5 is the same as 20 out of 100, so it's 20%. But you've got a calculator tomorrow. The volume of a cylinder, to 1 decimal place. Any volume, any prism, like this, right? You're told in the front of the book this, that volume is equal to area times length, they call it in the formula sheet. I much prefer the word depth, how deep the shape is. So here, the area of the circle would be pi times the radius squared. That would give you the area of that blue section here. Okay, and then times that by the depth into your calculator, round it to 1 decimal place, jobs are good on. Okay. I don't really like these trial and improvements that much. However, on the same line as you find an answer, you must write to 1 decimal place. Okay, all right, well, whatever. The solution to this lies between 8 and 9. Apologies if you see messages pop up on my screen. So we're going to start with the middle of 8 to 9, 8.5. So into your calculator, you would put 8.5 squared plus 3x. 3, 8.5. So you can use brackets to substitute a number, and I could have done that there as well. I could have done like that. Anytime I'm putting the 8.5 in instead of x, stick it in brackets, okay? Now, in this case, we're aiming for 94. Quite a lot of examples aim for 0. The examples we did, a lot of them in class, aim for 0. But we're going to put this into our calculator, and then we need to say, is our answer too big? Is it above 94, or is it too small? I'm not actually going to do this because it's going to waste too much time, and I haven't actually got a scientific calculator here, which is not great, really. However, let's pretend it's too big. You check, but let's pretend it's too big. If it's too big, we'd go for 8.4. and we'd try that. If it's still too big, we'd go for 8.3. And we'd keep working our way down until we get one too small. All right? Now I'm guessing here because I don't have the answers myself. If the answer is between 8.3 and 8.4, so if 8.4 is too big but 8.3 is too small, then we check the middle. Even though the middle between 8.3 and 8.4 is 2 decimal places, we put that into the formula. But this is just a check. Therefore, if the check is too big, then the answer is smaller than that, so must be 8.3. However, if the check is too small, then the answer must be bigger than that, therefore is nearer to 8.4. So that's the kind of setup I'm looking for. Start in the middle and then work from there. Let me see how long I've got left of recording. 4 minutes before this video will cut off. I can do a little bit more in that time. I might have to do this in 2 parts, chaps, okay? Yeah, it's easy. Okay, surface area of a cuboid, stunning. Area, not volume, surface area. So all the different things. So we got a front, we got a back, we got a top, we got a bottom, we got a right, we got a left, or whatever you want to call them, however you want to label them, right? Top, bottom, front, back, right, left. Each one we got to work out the area for, then add them all up. So the front rectangle, the front is 9 by 5. The back is 9 by 5. Then the top is 9 by 4. And the bottom is 9 by 4. And then the sides, the right and the left, as I call them, are, let's have a look, 5 in height and 4. So 5 by 4. And the left is 5 by 4. And we work them all out on a calculator. And then we just add them all up, okay? Right, we've done a bit of similarity of shapes. Which one am I going to pick out? I'll pick out this last one here, okay? If I want to find x, I need a scale factor. So that is my plan, is to use the 12 on that shape to get the x there. Okay, this is the word we're looking for in the question. These shapes are similar, okay? And our scale factor, please, a scale factor is how many times bigger, not add or take, or it's how many times bigger. So how many times bigger is that than that? So we'll divide the big by the small into your calculator, and that comes out as 2.5. So x is 2.5 times bigger than the 12 on the small shape, or 12 times 2.5, okay, which is 30, I believe. And I'll tell you, I'm going to add another bit in here. Say I put that this up here was 45, I don't know, and I'll put y there. Then to get y, we'd have to take the 45 and divide by the scale factor, okay, which is, I don't know, 10, 18, I don't know, check it out, I think it's 18. Okay, that's that. Okay, I'm going to stop the recording there and come back. I might have to merge the videos together into one big video, but there'll be a bit of a gap coming up in the recording. Okay, strangely, I've lost my pen. Oh, there we go. Right, welcome back to the second part of our video. Kicking off, we're getting towards kind of higher B stuff and borderline and getting into A grade stuff now, and the A star stuff's coming. Gross. Right, we're now looking at the right-hand triangle section of paper 2. Okay, so paper 2 will always have right-angle triangles. This is your Pythagorean trig section. We're going to know the difference between them. So, calculate the length of the unknown side. Right, we'll call it x, the unknown side. If you know 2 sides and you want to find the third side, then it's Pythagoras' theorem. In this case, if the missing side is the hypotenuse, the big side, then we will use square, square, add, square root. I might try one of these, okay, though. In these, so in question 40 and 41, or 39 and 40, sorry, we're looking for the big side, but in 41 and 42, we're looking for the small, or one of the smaller 2 sides, the base or the height, as it were. So if you're looking to work at the base or the height, one of the smaller sides, okay, then it's square. Okay, square the other, subtract, and square root your answer. And then whatever that is, guys, again, because I'm struggling without a calculator here, round that to 1 decimal place. Same here, chaps. Square that, subtract, and square root. Okay, trigonometry. I think with trigonometry, it's going to be useful. Let me just quickly, I'm actually just going to look what. Yeah, okay. Sorry to come back to you here. Right, I was having a little look at the side here at kind of the skills you're going to need here. You're going to need both. Okay, so you're going to need to be able to calculate a side, and you're going to need to be able to calculate a missing angle, right? Potentially within the same question. Okay, a couple of triangles joined together, that's quite common. So here, with trigonometry, why I know this is trigonometry is there's an angle given. Okay, in Pythagoras, there's nothing to do with angles. So this is trigonometry. So we've got h, which is quite useful because that's the hypotenuse. This is the opposite. And then the third side is the adjacent. Opposite because it's opposite the angle that's given there. Okay. Back to September, October, I suppose. SOHCAHTOA. Cross out SCT. Cross out the side you know. The adjacent we know is 13. Cross out the side you want to know, the hypotenuse. Don't cross out O because we don't know the opposite and we don't care what it is. So this is a question that's going to use CAR. I would draw the little triangle for whichever one you use, okay? Cover the one you're trying to find out. In this case, it's hypotenuse we're trying to find out. That's the missing one, okay? So to get the hypotenuse, it's A, the adjacent, 13, divided by C, which stands for cos. But when you put that into your calculator, it'll do that. And you have to put a number in the bracket. And the number that always goes in the bracket after cos, sin, and tan is the angle. So in this case, it'll be cos of 19. That's the number that goes in there. Again, you put that into your calculator, guys, as it looks there, and you give an answer to 1 decimal place for me. On the flip side, something that looks a bit more like Pythagoras' theorem, because we're given 2 sides. Okay, but this time, it's the angle that we're trying to find out. So again, we're going to start with SOHCAHTOA. Again, we're going to get rid of S, C, and T. Right? We know the opposite. We know the adjacent. The hypotenuse, we don't know it, and it's not relevant to the question. It's not what the question's asking for. Okay, so here we're using TOA, but we're trying to find the angle. And it's the sin, the cos, and the tan that link to the angle. Therefore, that's what we're covering. So we will write tan, could call it x, I like to call missing angles theta, equals O, which is 9, divided by A, which is 15. However, whenever you're finding an angle, you are going to need to do tan minus 1 or cos minus 1 if it's cos, or sin minus -1 if it's the sine button that you're using. Okay, it's a bit of trig for you. Now a little bit of 3D Pythagoras, that's in there as well. So calculate the length of the diagonal AB. This is this one here, which is nice and in blue for us. However, if we follow from B up to A, to make the right angle triangle, we'd need to come down from A and then back along the bottom here, and that is a right angle triangle. But to get X, we're missing the length of what I'm going to call Y. We're going to need to know how long that is in order to get X. Now, so I'm going to start, I could change the colour penny, but no, I won't bother. I'm going to start by looking at this right angle triangle, which comes from B along here, 5 centimetres, goes up here, 6 centimetres, and back along Y all the way to where it started, okay? So it looks like this. It's 5 along, 6 up, and then back down. Okay, so to work out Y, square, square, add, because it's the hypotenuse, square root. So y is the square root of 61. I might not even answer that because I might use it in the next part of the question. Therefore, looking at the triangle now that I'm actually interested in to work out what x is, which is kind of like the one I've been aiming for, I've got 7 here, but I now know that this length here is whatever the square root of 61 is. If I had a calculator, I might work that out to this point, but I don't, okay? Again, though, square, I'll tell you now that's 61, square the 7, add, and square root, and this time actually answer it and give the answer to 1 decimal place. So look for making 2 little triangles, starting with that one there. Same up here, guys, right? Start with that triangle there to work out that. Once you've got that, use this triangle that my pen is marking out here to get that. So it's using Pythagoras twice. Best one here, yeah, this one's good. This one's good. This one's good for the exam tomorrow. Scale factors again. We're talking about that word similar again. So always scale factors with similarity. So this time it's 1.5, but we're not talking about a length here. We're now told the volume of this is 400. What's the volume of this? So we don't actually want what I'm going to now call the length scale factor. We want the volume scale factor. Okay, and remember what I told you in class. If you want an area scale factor, you're going to square this. If you want a volume scale factor, which we do in this case, we're going to cube this. So I need to work this out. It's 1.5 cubed. Put that in your calculator, work it out. So the volume of B is equal to 400 times whatever that is. For a minute, I'll just write it as 1.5 cubed. Okay, because in fact you could just do it like that, stick it as 1.5 cubed there to increase accuracy. Okay, so volume scale factors, done that pretty recently. Same here. Here this is about area though, so whatever the scale factor is, whatever 15 over 12 is, you're going to be squaring it to get the area scale factor. Okay, right. Let's see how long I've got left. I am 6 minutes. I should get there, guys. Unfortunately, you can only record it in like 10, 15 minute sections. It's rubbish, but there we go. Right. There's 2 things they might ask you for here. They might, or 3 really. They might ask you for the length of the arc, right? The length of the arc is linked to the circumference of the shape. However, if it's an arc, then we need to times the circumference by the angle in the middle over 360. If they don't ask for the length of the arc, if they ask for the perimeter, just be a little bit careful here, because the perimeter not only is the length of the arc, but if they want the perimeter of the shape, we also need to add on the length of that, which would be 10, and the length of that, all the way back to where we started, which would be another 10. So there's like 20 we need to add on to our answer. But I don't know, without seeing the paper, I don't know if they're going to ask you for just the length of the arc, right, which would be the answer to that, or the perimeter all the way around. Either way, 10 is the radius of this circle. If you picture this circle continuing around here, 10 is the radius, so that is the diameter, which would be 20, okay? Like here, show that the perimeter. So with the perimeter question, we'd have to be adding on the 11 there and the 11 there, as well as working out the arc, okay? Okay, here's another perimeter one there. Just to mention though, guys, if I wanted the area of the sector rather than the length of the arc, the sector area. So again, I'm not 100% sure. Again, it would be pi, but instead of pi times the diameter, because this is an area question, it would be pi times the radius squared. So there we are using 10. But again, we would want only that fraction of the circle. Okay, the volume of a sphere. You don't have to learn that, it's given to you. Okay, so it's 4 over 3 times pi. It's on the formula sheet, just turn to it, times the radius cubed. The radius of this sphere being 8 cubed. Stick that in your calculator, boom, okay? However, this is not a sphere. This is a hemisphere, which is half a sphere. So your answer, I'd have to be remembering, no, I need to half that, because that is the full sphere here. Okay, but you don't need to learn that, just remember, oh, this is a sphere question, I can turn to the front of my book for that. Awesome. I'm having a quick look just to see if there's anything more I want to talk about. I don't believe there is. No, I'm happy. Okay. Sorry, guys. One thing, I'm just going to go back to this question here. I think you are going to need to do a sector area and an arc length. Okay. I think it is a perimeter, but instead of saying what's the perimeter, be careful for questions like how much string, what length of string would I need to go all the way around the shape. That's another way of saying what's the perimeter. How much material do I need to go around the outside of the shape? It's just another way of saying what is the perimeter. Love it. Yeah, hopefully that's good. Come back with questions. If you're struggling, what am I thinking you might struggle with? Trigonometry, maybe, because we haven't done it for a little while. Pythag should be okay. No, I'm generally quite happy, right? But if you want to come in the morning, I'll be there during reg time. Come and have a chat about any questions on there that you're struggling with. All the best. See you tomorrow.